Hello guys, welcome to Edu Success 2 Cross. Yesterday we saw how to derive the series and parallel combination of a resistance equivalent formula. So today we will solve few numerical based on those formulas. So let's begin with the first numerical. Okay, so first question says determine the equivalent resistance R across terminal XY in figure A, B and C. So for first part we are going to solve the equivalent resistance across the terminal XY. So in the first figure, you can see here the current that is flowing in terminal MP is equals to the current that is going in terminal PO. So the resistances of MP will be in series with the resistance of PO. In the similar way, the current that is flowing in the terminal MN is equals to the current that is flowing in the terminal NO. So MN resistance will be in series with the resistance of NO. So here we can replace this circuit as these two resistances are connected in series, so it will become R plus R. In the similar manner, these two resistances are connected in series, so it will become R plus R. That is giving 2R. Here also we will get 2R. So now, again this circuit will be converted in this form. These two R and 2 are connected in parallel. So R will be 2R in parallel with 2R, that is 2R into 2R on 2R plus 2R. So that is 4R squared upon 4R, that is equals to R. So this is the value of equivalent resistance in the first figure. Now let's see second part. Okay, so in second part we can see here this is the short branch is connected in parallel with these two branch, and this short branch is not having any resistance. So if any branch is connected in parallel with the short branch, so automatically the resistance will become 0. So here equivalent resistance for this branch is 0. Now for part C, we will find the equivalent value of resistance across the terminal XY. So here we can see this P and N are connected by a wire, or they are shorted. So this circuit can be made in this manner also. Here this is R, here it is also R. So now these two terminals are short. Here it is R and here it is R. So we can see here this PO is parallel with NO. So here these two resistance become parallel. R is parallel with R, and this also parallel, R is parallel with R. So here we will get R into R upon R plus R, that is equals to R square upon 2R, or we can also say R by 2. In the similar manner, here also we will get R by 2, and the whole combination will give us R is equals to R by 2 plus R by 2, that is equals to R. Okay, so moving to the next question, in a series circuit of a figure, determine the voltage drop of nth resistor in terms of the other resistances and the supply voltage. So voltage across first resistance R1 is equals to I into R1, because I is going in series with all the resistances, and voltage across second resistance is V2, that is equals to I into R2. So in similar manner, voltage across nth resistance is Vn is equals to I into Rn. So we know that I is equals to V by R, and R here is R1 plus R2 plus dot 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 plus Rn. This we have already found. This R is equals to R1 plus R2 plus Rn. This we have already derived in the previous lectures. So now we know Vn is equals to I into Rn. Now we will substitute the value of I from this equation in this equation. So V upon R1 plus R2 plus dot 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 plus Rn into Rn, that is equals to Vn. This is the value of a voltage across nth resistance in with respect to the other resistances or in form of other resistances. So we can write this as Vn is equals to V into Rn upon R. Next question. Question says find the equivalent resistance of the circuit shown in the figure. So we have to calculate the equivalent value of a resistance across the terminal X, Y. So we can see here these three resistances are connected in parallel. So equivalent value of a resistance across X, Y is equals to 10 parallel with 10. It's parallel with 10. So we will get 1 upon 10. 1 upon R is equals to 1 upon 10 plus 1 upon 10 plus 1 upon 10. So here we will get 1 plus 1 plus 1, that is equals to 3 by 10, or R is equals to 10 upon 3. So this is the value of equivalent resistance across the terminal XY. Next question says the current of 10 ampere flows in a circuit consisting of 2, 4, 10 and 20 ohm resistances respectively in parallel. Determine the current in each branch. So here the circuit will be formed in this manner. 1, 2, 3 and 4 resistances are connected in parallel. Suppose the voltage is V and current that is flowing is I, and that is equals to 10 ampere. And here the resistance is 2 ohm, this is 4 ohm, this is 10 ohm, and this is 20 ohm. And let us suppose this is current I1, this is I2, this is I3, and this is I4. Okay, so now we know how to calculate the equivalent value of resistance. So here it will become 1 upon R is equals to 1 upon 2 plus 1 upon 4 plus 1 upon 10 plus 1 upon 20. So here we will take the LCM, it will be 20. Now we will find the value. That is equals to 18 upon 20. Now this is the value of 1 upon R, so R will be equal to 20 upon 18. So let's find the value of V. So V is equals to I into R. That is equals to 20 upon 10, 20 upon 18 into 10. That is equals to 200 upon 18. So that will give us 11.11 volt. So now let's find the value of current across each branch. So I1 is equals to V upon R1. Because all the resistances are connected in parallel, so voltage will remain same across each branch. So V is what? V is 11.11 we have already calculated, and R1 is given as 2. That will be equal to 5.55 ampere. Second branch current will be V upon R2. So that is equals to 11.11 upon 4. So this will give us 2.78 ampere. Next current I3 is equals to V upon R3. So that will be equal to 11.11 upon 10. That will be give 1.11 ampere. And I4 is equals to V upon R4, and that is equals to 11.11 upon 20. So this will give us 0.55 ampere current. So this was the each branch current. We have calculated here all the 4 branch current. In this way we will solve this numerical. Hope you all like the video, and thanks for watching. Please like, share and subscribe and press the bell icon. And if you have not gone through the previous videos, so I will share the link in the description box. Please find that. Bye. Meet in the next session.